All right, team, welcome back. We'll continue with our Python tutorials. So we've been working on the API automation, and we've done a good amount of progress overall using pandas and data frame. What we want to do today is focus on understanding NumPy as a Python library. So most of what you'll see today is about introduction to NumPy and some of its fundamentals. And very importantly, as to why we require NumPy and so on. Few links, team, that you can refer later. I'll put it as part of our documentation with the training. And primarily, you have to begin. There is an entire website for NumPy by itself. You got the release and other things. But a good place to start for any beginner is with W3 Schools, or just looking at some of the code that we'll build, primarily oriented around a lot of these initial NumPy tutorials. Then we'll get into the random and the ufunc a little later. But what are we trying to do is the fact that we're still working with arrays. Excuse me. So what we had with our CSV earlier, you would notice that we are able to manage data in a certain two-dimensional array and so on. But with NumPy, you would notice that how it is different from lists. There's one more link that I put from geeksforgeeks.org, where it explains very nicely as to why our existing Python lists. So if you remember in W3 Schools, I also showed you about the different data structures that are inbuilt with Python, and all these collections that we have, different types of arrays, and what's ordered, what's not ordered, or changeable and not in that combination. And we also explored a lot with JSON and how we use that within our API automation overall. But the fact is, list itself is like an array. It's already holding data and information. So why do we need an additional library called NumPy? The summary or the conclusion of this entire document that you should refer to later, I put that link there, is right at the bottom, where we talk about very key aspects when it comes to our computer sciences. And as we get to artificial intelligence and building our own agents and so on, this becomes very important, because you have the ability to play with larger data sets that gives you more predictable outcomes. And that is where efficiencies in using memory, speed of how operations work are very important. And when we say convenience to use, it's all about the inbuilt functionality. So NumPy comes with a lot of inbuilt functionalities that helps me to work with arrays, be it a single dimensional or a multi-dimensional array. But primarily, if you look at some of these codes out here, where we import NumPy as NP as a standard that we've been seeing in the industry, and then you are basically trying to create a list of 1,000 elements out here with a range of 1,000 and get the size of it in bytes for each element, or multiply it by the length of it and get for the entire list. And the same, we're trying to do it using NumPy using the arrange function. And in this case, we're also doing the same thing. What are the total bytes for each item, and then total bytes for everything else. So that is where you'll see that for the first one print being element of list in bytes is 48 versus 8. So that's significantly higher, like 6 times higher out there. The same, you just multiply it with 1,000, using the amount of memory that is going to be used in bytes for the whole list. So that primarily is one out of the box achievement, but there's so many other things, team. And even, for example, how things are loaded in the memory. So, for example, as a list, we have them being randomly fragmented across in different memory locations, and you have lot of data or information as pointers to know where my list is available. They're not arranged sequentially. But when it comes to NumPy, just like an array, if you remember Java or some of you worked on it, it arranges them in a sequence within the memory. So that's those are some of the big achievements. And there's a GitHub library because it's an open source tool where all the latest pushes, the branches that people have been working on. It's a well contributed one, team, so you should definitely take a look at it and get some more details as you work through it. But the importance of it is the fact that these uh, few things that we'll learn today, like NumPy, Matplotlib, later, will direct us very specifically into the direction of machine learning and AI. So when we want to create a lot of agents and or different solutions which are AI driven, these technologies will become very important. So let's get there quickly. I wanted to maybe close these windows. I don't need them. Did I close them? Yeah, I did. And I'll move this down to my other screen. All right. So I was trying this lecture a little while earlier. Unfortunately, the screen or I was muted and the team couldn't hear. But then I quickly recorded this team and so here's an existing code. What we start with is primarily the important install, the pip install command, and let's go take that command into our terminal. Terminal is primarily within our Python project. We have our virtual environments for each of our projects, and that is where we're going to execute anything that we're doing. So, this link. Oops, we do Control C. I'm trying to copy this. So if this requirement is already met, it would say that requirement is met. It doesn't need to do anything. For some of you starting with it, it's going to download a few libraries and set up NumPy for this specific project in your virtual environment. So make sure, team, you remember how you get here, because once you get here, things are pretty easy. So it says it's already satisfied the requirements, so we don't need to upgrade more. We are already with the latest version. Let's see what was in. Go back and see that numpy.org to make sure that we are in the right version. But anyway, most of the standard features are there, team. So what's coming in latest, I've not seen anything good, but whatever features we see are brilliant to begin with. So first command, import NumPy as NP. So you can call it anything, but primarily we're saying that once we get that object, we are able to make it as an array, and that's one of the first keywords, team. What we're talking about is a single dimensional, two dimensional, three dimensional, or an n dimension array. At the moment, let's start with the beginning with a one dimensional array and try and understand what data am I storing. I can store any data, simple things like speed limits or miles per gallon that I have observed, or the different vehicles. So at the moment, I said, let's do the speed limits. What do we typically see as a speed limit on miles per hour when we are driving across our neighborhoods? Or so starting with 20 or 15 miles per hour, let's make it 15, and then 20, 25, just incrementing it. And at this point, all I'm doing is the A1 is now holding a NumPy array. So it's all about this import that we did with NumPy. And with that object, I'm able to work anything and do anything. So I can print the entire array. I can print since the indexing starts with 0, the fifth element in it, um, 0, 1, 2, 3, 4, 5. That would be 65, I guess. So no, the fourth. So 1, 2, 3, 4, 5. It should be, yeah. So yeah, I'm just highlighting this 4 and trying to look at where else 4 is there. That PyCharm ID is doing that for us. It's not giving the answer right away. Then the simple features like you can print the length of your array. Not that you need it specifically, but sometimes you just want to know the size. You want to know the shape of it. You want to know what is the data type, what's stored within it, before you get into the depth of understanding other details of an array, like relations, correlations, regressions, and so on. And what this code is also doing, I'll come to this in a little. I'm trying to get to creating a two-dimensional array here. A simple for loop where I have a range between 15, let's say, and 75, and my increments are 15. So what all would go into that if I created as an array? Or in this case, A1 is already my array. I know my length of my array, which is here. I didn't put it into variable. I'm just calling that function again. And I want to loop through this for statement and print all the items in this array. I starts with 0 and it goes till whatever is the length. 1, 2, 3, 4, 5, 6, 7. It wouldn't do the seventh one, but it'll print the seventh one. And each time it's going to print one in new line. This is going to print the similar thing, but only on increments of 15 out here. That's what we're going to do. So there's no relation between what lines 14 and 15 do and 17 and 18. But for you to experience what the code is doing, what is the syntax trying to do. So let's look at this. So the first print that we got, I believe, is for the entire array. And remember when we wanted to print line 1, it was pointing to 45 because 4 and 4 match, and the IDE took it that way. That's the one that is printing your number 45 or your fifth element in it. First, 0, 1, 2, 3, 4. So that's your fifth element. And then your overall length, the one is 7. And now you're printing x from 15. So it's what I have to, when we scroll down below, what do I expect to see? 15 is my starting range, as long as it doesn't hit 75 or till 75, plus 30 would be the next, 45 would be the next. Let's see, I don't know what all it would do here. But then this x has got nothing to do with A1. But visually, I would like to map. Out here, I would say 15, 30, 45, 60, and then 75. Would it come? There we go. That's it. 15, 30, 45, 60. That's it. Till there. And then there's nothing here. I'll just print. A delimiter. Let's rerun. So that way we know that a for loop is ending with 75 should not be met. And then in this, I'm just printing the entire. It's exactly like print A1 of like line 8, but line 8 is printing everything in one line, just like the array looks. This is achieving the same thing. So now let's go further. Let's look at it two-dimensionally. So what I'm saying, A2 dot equals, not A2 dot, A2 equals NP. That's my NumPy. And under this, you have all the different methods, options, um, data or variables that you can store. And there's a lot to explore, teams. So that's the beauty of the whole fact. But most important, what are the basic beginning ones? End of the day, our AI machine learning tools are data intense, and that is where our focus needs to be. So what we're looking to do is create an array, np dot array. There we go. So we're creating an array, and in this case, let's say I do 0, 1, 2, and then I want to create a second dimension to it. And I say there's another values 3, 4, or 4, 5 for now. Right? This is now my two-dimensional array, where from just basic points or data, it's got into a 2D kind of a vision where I have X and a Y axis. And you basically are trying to, one second, sorry, let me take it. So yeah, I'm back. Print A2. That's what we try to do. Now, there could be an issue here, and that's what I want to point to. At the end of it, the array, NumPy needs to understand that this whole thing is one set of data. So I'm basically going to encapsulate them in square brackets to begin and to end. So anytime I'm creating an array, I start with a square and end with a square, but dot array is important to create it, similar to a list. The same here, but within this, I have embedded two more square brackets, one for each set, one for each row. Now let's try and execute it. And I go slow, team, because this become very fundamental, important things, team. Even if you listen and you get a basic idea of it, it will help you master it over a period of time. If you do not get these fundamentals right, then you'll have to keep coming back and restart with the basics each time. So once the basics are there, it's very easy to come back. So how do we now create a three-dimensional array? So like A2, I'll just copy this for now and create A3. I can overwrite A2, but let's keep this. So what am I saying? Comma, one more. Visually, you need to look at them. What does it say? So these are, I'm sorry. A3. Visually, you need to look at it in a few things, either a graph or so on. But primarily, it's like data being available for you to access with columns and rows and more parameters. So you can use them as tags or labels and be able to arrive at something specific. And you can always create new arrays instead of, in this case, I'm entering data manually. But what if I want to create NumPy arrays that contain zeros, my keyboard is literally troubling. I need a new one. It's a small one, team. Sorry. I hate bad typing otherwise. So what are we saying? So I can say A1, I already have this, underscore zeros equals NP is still my NumPy or zeros. And let's say I want to create a three-dimensional array. all right, a 3 by 3 matrix. And each of these are basically, I need to put them into double encapsulation because you have these methods that are taking inputs to create something very specific. So let's look at them once we create. And I can do the same where I can do dot one. So look at the number of methods team that NumPy has. You over a period of time will explore a lot of the main ones and apply it to whatever projects you're working on. So let's do a 2 and 2 as well. And let's do an execution. This is A2 dot zeros. No, A1 underscore. I'm going to print A1 and print A1 1. So zeros and 1. Let's run this. So each time you don't have to specifically have to organize yourself team. So you can create templates of it and start replacing the data as you find. So you have your 3-dimensional array, all zeros, and a 2-dimensional array with ones. All right. What else is there? There's also the arrange word. Just looking and thinking of what all we can do. And there's the random. So arrange will basically help you to arrange. Let's say A1 underscore arrange equals you're giving it like a range. So np dot range. And you can give the starting value, the ending value, and the increments. Let's say I give 2. And let's run this. And let's also run for random. They'll get the difference. Then A1, go to arrange, and let's do that. Sorry, increase your speed just in case. A1 underscore random equals, and this is an important one team, random, and how we use it to come up with what we want to do. And right now we're only working with digits and numbers, but we could do a lot more with it. So random, let's see what this does. I've been speaking and not executing. A1 ran. So let's see the last print statements. I'm keeping all the early prints active. Not that we'll require, but all right, let's see. So any random number team, it's generating between 0 and 1. And you can make it a integer by multiplications and so on. But primarily it's going to be anywhere between 0 and 1. But let's look before that, what arrange is doing. 0, so this is the 1. It will go up to 10, but not to 10. And it's incrementing it by 2. And that's how our new array, NumPy array got created. In the random, I asked it to create a 2-dimensional array of 3 items each. And it basically gave me different random values for it. So by comment, but again, then you have to uncomment when I share this code team. That's okay, I'll not comment. and then I rerun it. Each time the random numbers should be kind of different. So what we saw in the previous run to what we saw in this run, each time it should generate different random numbers. And that's very important for us um, as we get into data sets which are very, very large teams. So let's look at a few more things on what else we can do. You can also do things like you have a large array and you can slice an array. An NP array, slice a NP. And what we're saying is I can take an array, like let's say um, 02468, so A1 underscore arrange, and slice it to only show me specific element. So A1 underscore arrange, and I'll say print between the second to the 10th element. And I don't know if you're already observing, our A1 underscore arrange doesn't have so many items, but then it will still take the third item. 2 is the third item, and then go all the way till it can hit the end of it. So you're slicing the array and you're basically saying, I want a subset of it. For example, if I do the same for A1, of A1 underscore arrange, let's look at this. Oops. And if you observe team, so far all the data types that we put are between or 2 to let's say 4. So you get to see the difference on what it is slicing. Is integers at the moment, just numbers, in fact, positive integers. And the same we need to understand if we can do it on different data types. So data type identification is also important. So I can always say print A1 dot D type, right? And it'll tell me what I'm holding in it. Now let's say I create A1 underscore text, A1 underscore T equals NP dot array. And in this case, what I'll do is I'll say this 1 is alphabet A, this 2, and this alphabet B. There's 4 items in this array. And now we'll ask it to print this type as well. Actually, let's do this. So this is A1 underscore T mix. And so this is a mix. There's a different mixed ones. And then we'll just put text in one. End of the day, data could be anything. What you interpret and how you use it is the most important part. I thought I'll do a very short session and all this I'll be able to cover quickly, but it's just very interesting, team, how you play around with the code, what you do with it, and what the outcomes are. So look at this. Did I print A1? Okay. What did I print? Only one data type. Out here, I'm scrolling so much. Integer. So the A1 array has integers only. But let's see what are the ones with okay. what is the type for each of them. So storage becomes important theme, and that is where you want to make sure that you basically understand the uh, fact that the different ways that the data can get stored, but eventually you can apply whatever you're doing into any of these. Let's do a new one, and we'll call this 10 NumPy 2.py and explore more. But let me get at least some of the basic arrays that will help us to play around. I need this, I need this, just a couple of lines. I don't know this. What are we doing? We want to do a few more things, team. So let's quickly at least write down what is it that we want to do, and let's start coding maybe in the next one. So things like copy, or you can add or combine or join different arrays together. The reason this becomes important theme is sometimes your, let's say in quality engineering space, your automation tests are running. And while the execution is happening, you want to be able to collect metrics or data as to what is happening, how many pass fail, what's taking long, what could be the root cause analysis, which tags we attach to the defects. All of this is happening live. So you should be able to alter your arrays at any point. So to do a lot of these things, you saw split, I believe, that we did, or things like how you could search for specific things are inbuilt with NumPy. You do not need to write specific programs or anything to achieve them. And when it comes to data, things like sorting or how we use random we observe, or how to apply it more, how we get a shape of a specific array, NumPy array that we build. And simple things like I want to, let's say, get a CSV file to NumPy array. How do we import it? So these things are very important as well, team, and that gives you the fundamental guidance that, okay, this is good NumPy. Now let's look at how we can apply it into our project. Great. I'll see you in the next session. Thank you all for joining. Take care. Have a good one.